but they are a powerful construct for solving some problems, and in some ways they make it easier. In other ways, sometimes you're better off to do a join. It just depends on the way your mind think is.
Should you always get the same results from the join as you do from the
Sure.
circle?
Yeah. It should come out. Yeah, there won't be a difference because if it was, then
Right.
then you wouldn't. It just means you didn't have the right solution. Yeah.
Exactly.
Yeah. So it should. The outcome should be the same. Okay. So first important thing is always have one of these already available to you, and sometimes it's better to even go sketch something that's a little bit smaller, so that you can see that. So because this one here, unless you get it out and paste it on the wall, it's kind of hard to see in the windows. I haven't gotten used to working in windows in these little frames. I'd rather have it all on the wall where I can see it. So that's just. So first of all, this number 6. What you wanted to do is to get a list of the patients who had the general panel. Now you say, well, gee, that should have been fairly straightforward, except you had to go through an intermediate table, and so I'm going to draw a picture here so you can see that intermediate table, and those intermediate tables are usually referred to as link tables. And this one probably could have been done with a joint.
As what kind of table?
Link.
Link table.
Link,
Okay.
link them together. And I'll explain that here.
So the joints include onto?
Yes.
Okay.
So here, I have the patient table. Again, just draw only the things that are of interest to you. Okay, you don't, they got a lot of stuff in here. I'm only interested. Got the patient. I might have patient, and I'll do something like this, and I'm going to need their name. That's what I really need, and the patient ID. That's usually going to be the link to another table. So that's all the information I needed out of that patient table. And then over here is the table. The other table had the information in it. Was the service, or in the service, the treatment service, service. And this had a service ID, and then we had some kind of description. And there was another column in there called category, but we're not interested in that because the category was what? Surgery. We were interested in the descriptions of the surgeries where it was. No, we weren't. Forget it. Okay, I'm just looking for something in here that was general panel. Okay. That's the plain old blood test. Or not plain old, but it's got most of the stuff they want on one swoop. Okay. All right. Well, you can see that's I'm missing something because I needed to know. I need to associate this with a name when you had that done. And if we were looking. Now we got the patient, we got the service, and there's a link of the treatment. Okay, that is a link table, and you can tell because it's got the hasn't got the key, but it's got that little this symbol right here indicating many records. Yeah, they call it. I'm gonna use the crow's foot here. As my notation. So I'm going to put the link table in here. and the link table is the treatment. Okay. And that's because a given patient can be having many treatments or many services. Okay. Okay. So each one of these is considered a treatment. Okay. Usually, if you're in the hospital, you're going to have blood tests, plus a bunch of other stuff they're going to do to you. Okay. So we need to have this table to make that connection. And we're going to, in a couple of weeks, we're going to talk more about the data modeling. But this simply says that for every record in here, I can have multiple records in here. It says for every record in here, I can have multiple records in here. So basically, it's a connection between the patient and the services. So one patient may have only one service, another patient may have 3 or 4 or 5. So, now what we'd like to do is, you can start to think of is that what I need to do is I need to have a list of the service IDs, and I'm going to call a list, of the service IDs for general panel. Now it turns out there's only one general panel in there, so if I make it a list but I don't know, it's okay. I can have a list of one item. So what? I don't care. Okay? Once I have that list, then I'll use that list to say, I'll create another list from this. Okay. And in this list, I'll have all the patient IDs associated with this service ID, which I've already pegged as the general panel. And so I may have a whole bunch of patients in here. Okay. Then I'm going to use this list here to filter out the rows in that table to give me the listing of the names. That's one way to think of it. I always think in terms of a list. A list can be produced by a subquery. And a list is nothing more than a list is one column many rows. Or a table with one column. Okay? Perfectly good. And when we have a table of just one column, we can conveniently use the in operator. Okay. And that's going to be suggestive of the 2 subqueries. So that means I'm going to do a subquery here. That one has to be done first, followed by this subquery, which then will be used to get my result set. So let's look at our solution to see if that is indeed what we would do. And I've already got that one up here. Where did I take that down? I don't want that. Oh, I had it. Okay. Right here. Okay. So, looking from the bottom first, so the important thing, I'm going to look at first subquery. I've got to produce a list, which will be used by this in operator, the next subquery. So I'm going to produce this list right here. Okay. And very straightforward. Select service ID. It's only got to be one column. Okay. From service, where service description is general panel. So I'm probably expecting, if I went down and looked at that table, I'd see, there's only going to be one row, one column. That's okay. It's a nice way of expressing it. Okay, once I have that list, then I'm going to look for the patient IDs. Okay, and here's my treatment table. And I'm going to look for the patient IDs that are in this list. Okay. I'm sorry, I'm going to look for the service IDs for a given patient in this list. Okay, that's straight. All right, once I have that list, okay, then we can go to the outer query. And now I'm looking for the patient IDs in that list. Well, the patient IDs in that list are the ones that have the general panel cut. Clear? Not too clear. Yes, sir.
I might have done a couple. If we use the, do an inner join with the treatment table, and then, but I still use the subquery with the general panel.
Oh, there's
And I
one
can
in
say
there.
for-
Yeah, yeah.
Yeah, that's what I did.
Okay. Fine. Good. Good. Yeah, yeah, as long as you get these names out there.
Yeah.
Yeah.
same name.
Okay, okay. Okay, yeah, there's several ways to do it.
Okay.
You could have done a join on all three of the tables and then filtered out by general panel. But since this was our chapter on subquery, we'll really work it over.
I used one, I just didn't get.
You couldn't use one. Basically what you did is you replaced one of them with a join.
Yes.
Okay? I replaced both of them with two joins. Okay?
So joint statements make precedent over the subgroups.
No, not necessarily. I could use one or the other. It's optional. But, so it's a matter of the way you think. So there's not a right way. This was an exercise on subqueries. So that's why they kind of guided you with their. You do this, and we expect you to do it with two subqueries. Okay. We all good on that one? Any questions? All clear? After there, that'll be fine. After he's turning in,
The last name used within the double quotes?
no, double quotes, in SQL Server, they're gonna use single quotes for a string. Double quotes are used for a label, but we no longer use double quotes for a label, and we're using the brackets in there. That's the new syntax. You go to any other, maybe another DBMS, they'll treat strings with double quotes. So that's DBMS specific. So it just depends on what you're working with. So you always have to keep that in mind. So what these declarative constructs here are what's known as SQL, ANSI compliant. That means it's a standard. So you should be able to take what you have here and use it in another DBMS. Well, not quite. Okay? Because you got things like this, little nuances. But in general, the syntax is the same. It's those special functions that are different. Like what you see in chapter 8, all those special functions. Date, time functions will be different. The formatting functions will be different. And, so they made a valiant attempt to standardize things, but it's been somewhat limited. And then the DBMS manufacturers don't want to be too compliant because they want to get you tied to theirs. Okay. All right. Okay, so let's look at the next one, and let's see what. Okay, this is the one where they'd like to have a look at the the services that were done where the actual charge and the service charge are different. Of course, anybody that works with hospitals knows that. You know, they've got a standard charge, and they always bill you that, and you look at it, and your eyes pop out. And then you know, a couple of days later, you know, you get your Blue Cross statement, and they paid all of that. Well, they didn't pay all of that. You start going down and look at the itemized listings and do a compare. You know, the hospital ends up getting about half. So that's what they contractually signed up for. So what it amounts to is this is a good example here of yeah, they're gonna, you know, if you don't have insurance, you're gonna pay that, you know, the actual or the what do they call it here, the service charge. You're gonna pay the service charge. Okay, the actual will only occur, or if you don't have insurance, the service and the actual are the same. Okay, for you. Okay. Unless you stiffen people's belly up. All right, so what we want to do is go and get that information. Okay. Okay. Well, if we look, we go back to our diagram. We go back again. Go back and look at your diagram. And so the service charge. Okay, you can see that that's gonna be in the service and an ID and then some kind of description. Well, and then for a given category. And then we have the treatment, because that's where the actual charge is applied. So we need to join those two tables. Okay. And let's see where we did the sub-query on this one. If we need to do that. Let me look at this one here. The other one made sense on a sub-query. Also made sense on a join. Okay, now we're going to separate out where the service category was surgery. That's what we need to do. So first of all, what we want to do is this is an author solution, and what he's done here, you don't see this much anymore, and I'm going to do something, is this is the old syntax for, and your book covers this, it's a good point here. This is the old syntax for a join. You just do a table listing, okay, and then you join on the primary keys. And my practice when we were doing that type of thing was, I like to associate that. I'm gonna take that one out like that and Control X. Take that one out if I just do that, and then drop this down, okay. And then I'm gonna put this in here. Okay. What they did is that they created, when they you do a listing on the tables, spread that out a little bit too so we can see that. Spread that out. Spread that out. So when we do a table join in the old syntax where we do a listing, my practice was that the first statement in the where clause, you know, basically that's what joins are doing. It's joining on common columns. It's filtering. Okay, only the things I got to match are going to be in there. I would put that first to indicate that was the join. Then we have the and over here. And then we have two conditions. One is where the service charge and the actual charge, there's no difference, okay? That's when you paid full amount. So we weren't too interested in that. We were only interested in the ones with the difference. Okay? And then when the service ID now is going to be in that category of surgery. So I've got to go to another table to get that, and that had to be in the service table. And again, could have done the whole thing with the joint. Yes, sir.
Sorry, this is another one, but the wording button, because it said produce a list of the services listed in the treatment table. Well, in the treatment table, are the treatment comments. So that's what I pulled, because it said.
Let's see, here's a listing of services listed in the treatment table by service ID where the prescribed, okay, the result table should also include charge of surgery. The subquery should produce, they're just telling you how to do this thing. Okay. Now, produce a list, I don't see your question.
Well, there isn't a services field in the treatment table, so
So
that's how they have it worded.
I just put the treatment comments as a service.
Produces, let's see.
Versus the service comments.
Produce a listing of surgery services listed in the treatment by service ID.
So I've used the treatment comment.
Yeah, okay, the wording. Okay,
That's what got me, so I
Yeah.
just called it service, but I used the column from treatment comments.
That's fine. Yeah, good. Your actual service description is gonna be over here.
That's what they were trying, I guess. to
Yeah,
get you to
they were,
look over
yeah.
here.
Yeah, I actually don't have a service ID column. What I actually did, I just have the service charge, the actual charge, and service category.
You're gonna have to have you can't just have a service category. You would have to have because it's the whole category it's gonna be surgery. Okay, and you're gonna get that out of here. So if we go back, if I so all we're going to do now is to find a list, okay, of all of those specific service descriptions that have a surgery category. And then we use that after we've joined those two tables, okay, to use that result for the filtering. Everybody follow it now? Yes.
In the select clause, why don't you have service charge and actual charge listed with the places you're getting from? Why doesn't it have a T and an S in front of it?
I'm sorry, ask it again.
So where it says convert character 12, why doesn't it say S dot service charge?
Because I could, that's a prefer, but it doesn't have a problem with that because it's not ambiguous. In other words, there's only one service charge in that set of tables. Okay.
Thank you.
When there's two sets of names, then I got to, for example, we have an example, service ID. I don't have a choice here. Okay, because it needs to know who belongs to what. Even though I know in Access, they go and resolve that for you. Okay, but that's not true in SQL Server. So what we did here is that, go and find all of the surgery categories, surgeries, treatments associated with us, and they associate it with a service ID for a category of surgery. They didn't ask us for the names here. I think they asked us for the names on the next one. That's where we get the one on the next. Okay. All right.
What is the one in the formatting? What is that one?
Oh, that's a comma, thank you, because this is a money type. And then here's your dollar sign thing that I, okay, just concatenate it in there. Okay, it's just a constant column. And it, it sits right next to the output, so it looks like you've got it's all one. There should be, I kept thinking there was a money formatting. I think there is on SQL Server 12. We don't have 12.
As money.
Pardon?
Just like an
As money, okay. Okay. Probably doing that all the time, right? Okay. If you're in the banking area, okay. So that was the case. This is old time way to do it. There's new time for that. It's a money type. Just do it as money. Okay. All right. Okay. Please turn off the phone.
Were we supposed to order that by
I don't think so. You could. Looks like these were ordered here anyway. They look ordered. They just turn out to be ordered. And probably the reason they're ordered is because they probably got ordered out of this select clause here. Okay? Everybody good with that one? Okay. And then on the number 9, basically you use the above query, and then what it wants to do now is what services are where the difference is greater than the average of those that have the differences. Okay. And that should be relatively familiar because we did something like that in the lecture last week. So we'll look at that one. So it sounds bad until you get closer to it. Here, they wanted the output with the service ID and the description. That makes a lot more sense. I like to see, what ones where they actually charging a high difference. And there was a big difference. It looks like these would be real expensive, and the insurance company says, no, we're not going to do that. We're going to really think of something a lot less. So the differences would be larger. So again, what we're looking for here is that this subquery here is going to be that one average. So it's going to go back and take that table and compute the average of all of those that are with the differences. And I think on this one here, I went and changed this so we had the joins in here, and that was a lot cleaner. So you see when we use the join, it's all one statement, so that your where clause actually serves as your filter, and you don't have that all mixed up. And then we got to compute the average of the differences. The average of the differences. That's all we were interested in. The others we didn't care about if they were the same. And and then we did a join on that one. That was convenient rather than do another subquery. So I just took the, I actually did the join, that was a subquery. To actually get those service IDs and then list the service IDs. They're in that list and okay.
10 more seconds on that, please.
Oh, I'll put the solution out there for you. And that was the one you were at.
Yeah, the tutor meetings are
Take
developed.
them out. When you have it? No.
Can you do that without anything?
Sure. I think the joint's gonna help you there. This one's a little bit messy. And yes, subqueries are difficult to get used to working with. They can lend themselves to some nice elegant solutions. Pardon? That's a habit of mine. Okay, because I started out in that wonderful world called the command line, and I had to terminate it with a semicolon to say, all right, that's the end of it. Go ahead and write. Okay.
So it's not necessary, it's just.
No, not in this environment. It already takes care of itself. But if you put a semicolon in there, it's just, so you can tell I doctored this one because I must have stuck that in there. They had the listing in our solutions in this set, and that was too much. That was ugly, and I don't like to mix them up. It's better to use this new join syntax, and the join condition goes with that. Don't put it in the where clause, and think of the where clause as the things that filter out my row. Yeah, it does. A join does do filtering on the rows. It says I'm going to filter out the rows that match up, and everybody else gets discarded. All right.
This is, one to show you what the tutor has with that, that's what you're trying to find.
Okay, that's fine. Can we discuss that afterwards? Yeah. For those of you who are working with the tutor, I didn't know who she was. She did contact me today, and I will send her a next week's set of solutions. For those of you that are gonna, I guess you're meeting on Tuesday nights.
Yes.
Okay, so she should have a solution for Tuesday night.
Is this free?
Pardon?
Yes.
Yes.
Wow.
She's up here from 6 to 9. She sent out an email to some of us.
Yeah. Her name is Angelique Chain.
And she's over in the tutor van.
Yeah, H142.
There's a bunch of you. You probably just go into the lab. And incidentally, the lab has SQL Server desktop on every machine in there now.
Yeah.
It's here.
Yes.
Huh?
Is it
Yeah.
She's down at the other campus two days a week, but that's supposed to be for Java tutoring. Supposed to be.
Should be on Tuesday night if you need some help.
What other ones? All the classes.
That's it.
Yep.
Well, you gotta be lucky, because I didn't know she was even gonna be available. I didn't know about it until Richard told me. Okay, so that helps you out. Great. I just what you mean.
We meet, so a group of us will meet informally without the tutor on Monday. And the tutor happens to be down where we meet on Monday, so we could probably all gang up on her, I think we outnumber.
Well, you gotta be careful. All right?
Yeah, 147, H142 is a really big room.
Yeah.
Not even a room.
Yeah, there's about enough for 5 people in there.
Yeah.
Yeah, that's the equivalent size of 2 campus closets.
H what now?
142. It's right around the corner, down at the end of the hall, way down at the end of the hall, and then the first door in there. It is an old server room.
You talk about PRC or?
Here.
Oh, here. Oh, okay, I know what you're talking about. Yeah,
That's where we meet on Tuesday.
that's the tutor day.
Yeah.
Okay, yeah, that's not very big.
But on Monday and Wednesday, she's down in J119
Okay,
in Spring Creek.
I got it. All right, any other questions? I'll put the solution out there so that you can compare yours to that. Not necessarily, it's one solution.
And you said it's fine if our solution doesn't match that exactly.
No, I wouldn't expect them to match. I mean, it's because there's multiple ways of doing it. That's going to be true in doing queries. In fact, that's true in any kind of program.
As long as we get the results, like,
Well, yeah, in the general idea. Okay. Any other questions? Okay. That is the end of our declarative constructs. Okay, we're going to switch gears. And what we're going to do over the next 3 weeks, I expanded this one, I think, this time to brief. Last time I lost a bunch of people on table construction. I started earlier and I went too fast. So probably for some of you, I might be going too slow. So I'm going to err on that side this time. So we'll talk about basic table construction tonight. Next week we'll talk about working with table constraints, which is the most difficult part, but the most meaningful part, because that's the thing that's going to guarantee you data integrity in your database. And then we'll look at some data modeling, and we'll design a little mini database. This is the one that weeds everybody out, okay, because it's going to be a slacker. No, it's not meant to weed you out. It's not meant to be. You're going to be. DBAs are the ones that usually do all the real table stuff, and so it's mainly just to give you a feel for how to, what that process is, and that you can actually do it yourself, and kind of just gives you, some background. And there are folks that are primarily analysts, and you can actually, do some of your own. And we're going to look at some of the alternative table creates that allow us to do things on the fly. We'll be going back and reviewing some of those, namely that common table expression. Okay, so tonight the way I'm going to do this is I'm going to go through a high-level description here so you can see it, and then we're going to actually, everybody, same time, we're all going to walk through it very carefully and create one table, right from the start. Create the database, create one table, populate it from a file. We're not going to do any insert statements yet. I'm going to do it the easy way. At least I think it's the easy way. And some of this stuff is not in the book. So I'm going to just give you the high-level look first, and then we'll do the hands-on part. But be patient. You're going to have to, deliver a table tonight. And then you'll have an assignment to do a whole bunch of tables. Okay, that'll be fine. I'll put it out there afterwards, because you won't be, you shouldn't have any trouble seeing it. All right, here's the basic table create statement, and your author is pretty sparse. I think it's in chapter 2, and that's about it. It involves the keyword create, and keyword table, and then you give it a table name. And I'll have an example here. It's going to be a table name that's usually representative of what you're storing. I'm storing employees. I'm storing products, whatever it is. Okay? Got a set of parentheses here. In here is going to be a listing of a column name followed by a data type. Okay? This is the one that's going to give you some heartburn because you're with programming types, they understand data types. But we now have to be specific about what we're going to tell the compiler we're going to store in that spot. And then we've got some modifiers after that that we apply to the column called column attributes. We'll look at some examples of that. That's where we're going to apply the primary key. And we'll have a listing for each column that we want to have in our table. Got to give it a name, give it a data type, and some optional attributes if we desire that. After we've listed that, then we'll have our table constraints. I list them here, and when you see the brackets there, that means it's optional. So my table has to have at least one column, and that's it. And for analyst types, I've had tables with one column. That's all I needed. If I was in a programming language, it'd have been an array. But it was, I'm in the database world, so it's going to be a table with one column. Okay. Any other columns after that are optional. Usually have more columns when you're going to store things. Next week we'll talk about table constraints, so we're not going to talk about that tonight. And an example of that would be if I was keeping an employee table. I'm going to kind of dissect this so you kind of get a feel, and then we're going to go and look at some detail. So here I've highlighted in the red, create table. Okay, those are key. Yes.
Why are the parentheses like that?
Why the parentheses like that?
Make it easier to see.
Oh, you mean why do I do it there than instead of doing them somewhere else? Make it. You answered it. Make them easy to see.
Are these PowerPoint slides out there right now?
No, I'll put them out there. I just got a few. You don't have to copy this stuff down, but give them to you. Unless you just, it's good to make a few notes. Good. All right. And here's my first column: employee number, name, age. There's all my optional columns. The next item in there is going to be a data type. Okay. And we're going to go through the data types here in just a minute. I can have things with integers. I have different types of integers. I got tiny integers in this one. I can have a variable character. Means I can store a variable versus fixed character. Talk about that. Small date and time. Okay, we have a date and time. And probably one of the more common ones you'll work with is money, okay, or currency. Pardon? Money. And the not null is a column attribute. So this is the only column attribute I got in here. And what that's going to mean is that entries into this column and this column and this column are required. I mean, it's required. But I'm not going to be able to insert a record if I don't have at least those three columns. The others can be empty. And then they'd have null, which means, and what it means is there's no entry and that means that little flag bit on each of those fields is set to 0. These will be set to 1, okay, because I've had an entry. Okay. And that's the thing we test when we look to see if it was null or not. Okay. All right, so this is an example of a table. So we're going to look at the details of the data types and the column attributes. And then we'll be ready to do some table creation. Okay. The TLSQL data types. Data types will vary somewhat across DBMSs. They'll generally be the same. First category is character type. We'll have 2 types of character types. One is referred to as fixed field. What we mean by fixed field, that's the character, and it simply says if I have character 5, it says the field is fixed to 5. That means it's always 5 bytes, 5 characters. If I only fill up the first 3, this gets padded with spaces. That could be undesirable if I'm doing string comparisons, because what I have to do is I have to be sure that if I'm doing comparisons, and this was in here A, B, C, I'd have to make sure it's A, B, C, a space and a space with the double quotes around it. So generally when we have, you want to use fixed field format or fixed character format when you have something like a product code. Our product codes always consist of 3 characters and 2 numbers. So it's always filled with something, not with spaces. If we have something that's highly variable, like names, addresses, cities, states, okay, then we use variable characters. For the state designations, it's going to be fixed, because this only needs 2, don't I? And the primary zip code, that's 5. It's not numeric. You don't do arithmetic on it. It's character field, so that'd be a fixed format. I say fixed format. Character. Yeah, or variable character. Yes.
Can you fix the field to where you have 3 alpha and then 2 numeric?
You don't fix it that way, but you'll have to, if you need to do that for verification, then you have to do some parsing.
Can't put like a restraint on the field. Gotta be this and that.
Ask your question again. What do you
You
say?
can't put a restraint when you find the field to indicate whatever.
Not in that case. Because it's character, still character.
Right.
Now, if you wanted to, make your, if you had some application where you said, well, let's take that example, and so our numbers, but that would require a lot of extra processing. I could have, you can think of it as my actual product number being, 2 fields, one with the 3 characters and the other with the 2 numerics. Okay? But what that means is that then I've always got to be working such that I've got to, include both of those fields. And you start doing your queries based on that, and then it becomes a little more complex. But you could now theoretically get things mixed up. So your downside would be it's better to generally what you do in the database is you're gonna actually have you'd actually have to, initially, and we'll see how to do that with our procedural constructs, is go through it and look at each character, and it doesn't match in a range. Whatever those values need to be. And same thing here on the numbers. And then you put that in an index, and then it's fixed. Okay? So that's getting down to some pretty small detail. Okay, integers, we have 4 types of integers. They're based on size. What do you need? Don't use more than you need. So the big integer is going to be 8 bytes. Okay. The regular integer is going to be 4 bytes. And that size determines how large a quantity can I store in there. So this would be, in this case, it's going to be 4 bytes. That's 2 to the 32. And so it can have a number as high as 2 to the 32. But we have one of the bits that for a sign, so it's really going to have the range of 2 to the 5th.
Negative 2 to the 16.
Yeah,
2 to the 16
Yeah.
minus 1.
2 to the 16 through 2 to the
16 minus 1. Should be just one less than the same
It's
thing.
going to be
50.
value. Right, no, yeah, because I've already taken out 1 bit.
Yeah, but that's the minus 1. Should be 16.
No, the minus 1, no, the bit is taken out of here. The minus 1 is because I'm going to go from 0 to 2 to the 15.
I got you. But,
Okay?
but like some of them, it's like negative 128 up to positive 1, or up to positive 127. So those are the same exponent, the one's just slightly smaller.
Golly. You're right.
I'm not going to remember these numbers anyway.
No, that's all right, that's all right. They're, actually, they got them all spelled out. I can't remember, what the numbers are. Now, I'll get down to here, I'll remember the small n. Okay. It's, the small n is, small, and it's,
That's the 32, 5,
2 bytes.
26 one, I think. It's a 32,000 something.
Okay. And that's, to the 15 total, and then that's to the 16, okay. You just divide it out.
Yeah, it's the negative 120.
Yeah, and then we got the tiny ant, okay, tiny ant, okay, and that's 1 byte, okay. And that's where we go from 128 to 127 minus 128. So for the most part, you look at this range here, and it's going to be like, this one will be close to what? 32, 767. So if your numbers are, a lot of integers in the business world are going to be in this range here, so use a small e. You got to have something larger. The decimal is going to be more the norm. Well, it's not necessarily the norm. We have quantity fields and stuff like that. If your quantities never get any bigger than 127, which is not, probably not a good choice, because some quantities can get much larger than that. So the small end is a good choice. Now, the way the decibel works, so that you understand that, is decibel. And it has two fields. It has what's called the precision, okay, and that's a kind of a misnomer. And this is the scaling, which means the number of decibels. What this means is the number of digits of representation. And I'm going to give you an example. I've got 1, 2, 3, 4, 5, 6. I've got 1, 2, 3, 4, 5, 6. I've got 1.2345 The digits of representation for all of those is 6, because I have 6 digits. Okay. So 6, 6, 6. Okay. In this case, what's the scaling? No decibel? 0.
Do you have to just get a zero there?
If you leave it out, it's a 0. But you're not going to do that, you know, if you're intending for that to be that way, then you might as well use an integer, because basically you're going to truncate any fractional part. So generally you're going to have something. It says here I want 3 decimal places. Okay. Here it says I want 5. Now you're not usually going to cut it that close. Okay. So, and you can have scale it. You can have precisions as higher. So what you have to look at is what's the largest number I'm going to represent. Okay, that's the way you decide. And then how many decimal places do I want? Okay. And then
So if the 1, 2, 3 point 4, 5, 6 is that one, doesn't the decimal point hold the bracket for the number of digits? Decimal point, doesn't it count as one place value?
you mean in the digits of precision?
No, I mean like 1, 2, 3, 4, 5, 6. Can we consider it as 7? I mean it's still.
No, it's not 7, because I've got 5 decimal places.
Yes.
I got one of these.
And the point itself.
No. That's
Because in some simple, like the field width they take.
no. If you did that, you're representing that as characters. Yeah.
Oh,
Okay. We're not doing that. But this is nothing but a symbolic representation here. Okay. Yes, sir.
Sometimes in programming, to save space, we use flags, or we'll set a flag, which is just a single bit. I was wondering, the tiny int is a byte. Is that the smallest thing? Are you able to set
when
flags?
you start doing flags, and you're getting off into another area, is that what they'll do is they're not going to use a whole byte to do that. What they'll do behind the scenes is as soon as you create your first flag, they'll create space and then use 1 bit in there, and basically they're creating a little vector in there. So it's going to be where you have and that's all done within the programming language. So that's kind of hidden from how that's represented. But no, it only needs a flag only needs 1 bit. It's on or off, true or false, yes or no. So what they do is they've got a space in there in memory where 1, 2, 3, and the smallest is going to be 1, 2, 3, 4, 5, 6, 7, 8, okay? And so they'll say, I'll allocate, one byte, and I could have 1, 2, 3, 4, 5, 6, 7, 8 bytes. That's all. We don't have to worry about it. Okay. The questions on the decimal? Just think, what's the biggest number I got to represent? Put that in as your precision. How many decimal places do I want? And put that in. And it's got to include, the precision has to include the decimal place. It's the total number. And that's all you have to worry about. And you got floating point, we'll use plus with that. Monetary is nothing more than a decimal. In fact, money is decimal 19,4. Okay, so it always works with fixed format decimals with 4 decimal places, and then rounds off for any kind of display. Okay. And there'd be no difference in using decimal and money, except when you use money, you're going to get set yourself up to be able to use some of the money formatting. That would be the only difference. And if you're the way to decide, do I use small money or big money? Small money can represent dollar values up to approximately $214,000.
A house.
House? No, they're not. I don't know what house you're talking about. Okay. Houses are usually going to be a little hot. Well, it depends on. I guess there's some houses that are still below that range. But,
How does that kind of compute?
how do I get?
How do they?
It'll be based on the size of the memory. It's the same way when we did the integers. In other words, how many bits of representation can I have in memory that would give me a combination such that I can have 214 as the highest number? In a good way, the easiest way to think of that is go back to 1 byte. It's going to be the same type of analogy. I have 8 bits in here. How many combinations of ones and zeros can I have in there? Because that's the way it's going to be represented. Ones and zeros. Okay. I can have 2 to the 8th number of representations. So what's the biggest number I could represent in there? I can have 256 combinations. If they're all 0, then that's the low range. And so if they're all 1s, then that would represent 255. And then any combination of 1s and 0s are going to represent the range of numbers in there.
I was just wondering, you fixed the calculations back 2 to 16.
Yeah, that was for integers. It doesn't work out that way convenient for the decimal. They're doing that behind the scenes, but I don't know what that is. We don't see it. And usually I don't have to worry about that. I just added some either enlightenment or confusion here. Probably confusion. Okay. All you have to think about is that, you make a decision, do I use money or small money? because small money is going to be, I think it's 4 bytes, and the date and time is 8, maybe larger. Okay, and so if I can get by with small date and time, and the criteria here is, I just say, if it's less than 200,000, like prices in a store item, small, but it's going to give you, your database size is going to be, for that field, it's going to be half. So that, but you don't make those decisions anyway. Because that would be what a DBA would think. That's how people think. Because he's going to be looking to, keep that table as small as possible, assuming you're going to have millions of records. Okay. All right. Okay, column attributes. We're going to look at the various column attributes we can have on here. One of them is the null or not null. So after I've put my column name in, and then after I put in a data type, then I can say either I can just leave it blank, and null is the default, which means I don't have to enter anything. If I put in not null, that means, what it means for us is I've got to have a required entry when I insert a record. I have to have a required entry before I insert a record. That would make sense, like on the employee. We can't have somebody without a name. Okay? And nobody else. What else do we have? ID. We got to give you an ID. And then we gotta decide that, when we hire you. And after that, everything else was not an example, it was optional. That's just an example. Quite often, most of the fields are going to be required. Okay. As an example, okay, here I got the name, okay, and not null. And quota, okay, it says, well, right now you don't have a quota. Okay, so, we could do nothing with it. We wouldn't have to have an entry. I don't have to put this word in here. It's just nice documentation. If I leave it out, it's null. Okay. No entry is required.
Your question?
Yes.
What if you want your column name to be month?
Don't do that.
Don't be that.
If you gotta do that, and it's just, it just has to be, then you put it, yeah, M-O-N-E-Y, and put brackets around that, and that says literally. I want to use that sequence of names. So you gotta go through the heartburn of putting that brackets around there. You have a question? So, if you just have to do that, then you do that. Because what's going to happen is it's going to show up blue. And then if it's not in the right place, it's going to say, wait a minute, I'm not expecting it here. Okay. But if you put the brackets around it, then you'll be okay. Okay. So I just I kind of expanded the table here so you can see some examples of every possibility. Employee number and name, yeah, it's got to be not null. Here I documented it. Okay. We're not going to ask you for your age, but they probably will. Okay. And then here, that means no. I didn't do it. That's the default. Okay. Okay. Any questions on that one? Yeah. That just means I got more here. That's not a legitimate construct. Okay. That's just.
Ellipses.
Yeah, the ellipses that I put in my, yep.
Okay, don't shoot me here. For your column name, what if you wanted to use a special character? Like a Spanish N or a Greek symbol or something like that? Can you do that?
You're out of luck.
Okay.
Now, when I say that, what you're getting into is what's known as the national character set. So if you're working in a, you know, in an environment where you have those kinds of things, then you have to use some other special libraries that are going to have you. And sometimes I think the term is code page or something like that. And you got to be able to, your keyboard's got to be able to work with those too.
Yeah.
So those of you that are working in the international community where you have international stuff, you got, yeah, that's special format, yeah. That's going to be out of the realm of our discussion in this class.
Thanks, I just want to know who's possible.
Oh yeah, absolutely, yeah, it's going to, but it's going to be, there's going to be some other, and usually you're not going to worry about that because that's going to be the you know, the DBA part for. Yes.
Does it have to start with a letter but can contain a number or
Now
something?
you can have, all right, golly, I think on SQL Server, because the language in that, I can have, I gotta start with the character, I can have numerics in there, characters, that's numerical characters,
Underscores, okay.
underscore, and I think there may be, that may be it for SQL Server. On Oracle, they'll let you put a $sign in the sequence of numbers. It just can't be the first one. It could be the $sign afterward. There might be something else. Now, okay, so, but again, you know, for your column name, now be sensible. You're gonna, you know, you want to put real names in here, but underscores quite often are because they, you know, sometimes they make the column names cryptic and put some other prefixes or suffixes along with that. But I can't recall. You have to look into the book. I'm almost certain now. I think the SQL Server is just going to be the underscore. But I know in some of the other DBMSs there might be the $sign, and there may be another. That sign will be used for a variable name, so that's not a column name. All right, we got another thing called the identity attribute, and what this is going to be used for is for generating a sequence of numbers that's going to uniquely identify each row that you insert into the table, sometimes referred to as a surrogate number. It's always going to be unique. It's going to be one identity column per table. Okay. You can have that. You don't have to have it. Okay. And so anytime you insert a record, then the next available number gets put into that column. And that's good for when you're creating invoices and stuff like that, because you don't care. It's just, you know, I just need a number. And it's got to be unique. It's only going to be generated once. Okay. Not reused. So it specifies an identity column. We'll see how we use that. Okay, it's only going to be one column per table. Okay. And, so I got to do this with an example. I've got 3 examples here. So I got something called sequence number, integer. It's got to be an integer. Okay, identity. By default, it's like this one here. It starts with 1 and increments by 1 each time. Okay. I got this. It just creates in other words, it creates an additional column, okay, So if I have a table here, and I got, usually I list that one first in my table statement. And this, I'll just say sequence none, okay? And it'd be identity. I'm drawing my table. Okay. Okay. My sequence none would be here. And as I insert the records, it's going to be 1, 2, 3, 4.
It sets up the primary key.
Huh? No, you shouldn't use it as a primary key, and the reason you shouldn't, because a primary key ought to be something that identifies the data. So this is just simply a, what I
Kinda like a
refer to as
record.
ser- Yeah, it is unique, it does fit all the criteria for a primary key, but the other thing is the semantics for a primary key should be something that identifies it. Yeah, like so. Now that's a surrogate key, though. Actually, it's just like one of these, but somehow we get associated with that number and we don't escape it. Okay.
So, is it something like the auto number? And
Auto, yeah, access. It's auto number. For those of you who had access, you're supposed to have had access before you took this course. Okay. Okay. And auto number. Exactly what it is. It's the
So when we say IHT 100, 1, does it mean?
We're going to start with 100, and we're going to increment by 1 each time. I could have 10. I could increment by 10. Usually you want to do by 1, but you know, somebody always wants to do something esoteric, and so you got some options here. But usually it's start with 1 and increment by 1. And if you do that, you just put the identity keyword there. I got one example for invoices. I might want to start my invoices at 100. And now my invoice table that's fixed for that table for the rest of its life. I can't tamper with it.
So once you put it in,
That's right. That's what you want. Okay. And you delete records out of there, it doesn't go back and reuse that number or anything. But that makes sense because invoices, I want to, after it's paid up, I'm probably going to archive it somewhere. So I've always got that invoice number. Now, in that case, it'd be a primary key because that makes it comparison. It's just a number. Yeah, no, nothing magic. Okay. But if you typically, sometimes you just want an extra sequence. There's this thing called the default, and now this is where we can actually put a default value when we don't provide a value for entry on an insert statement. We'll do inserts next week. So I can use the keyword default and say what the value I want it to be. If I don't provide an entry, then it'll put that value in there. So in this case, this was an alternative way of saying this is required. Okay. Instead of doing a not null, I can just put a default. Because you're always going to get a value. You don't put something in there, you get the default. Okay. So there are folks that do it that way. That probably that's the thing that probably makes the most sense. If a default value makes sense, that's the catch. So in the case of our target and our sales in our little table that we had shown, it doesn't make sense to say, well, you don't have a quota. Right now you don't have a quota of anything, so it's 0. You have no sales, it's 0. Okay. We'll assign you, a target later, and then hopefully you start, producing some results that look like you're moving towards that target. Okay. So here's my, still got it in the not and all there, because, a default on an office number doesn't make a lot of sense, turns out to be the basement. Office 0, and here's the basement. Find a spot for you somewhere. All right. And here's my favorite, because this is a real handy one. When we got a date time function, and we're creating dates or creating invoices on a certain day, heck, we got to put a date in there. We'll just get the date today. Get date gives you the current date right now. Good. So that's a good example for the invoice date. An invoice date would be required. You produced an invoice that's got to have a date, and it'll be the day you created it.
You know, if you make that like a small date time, does that automatically?
Try it. I'm not sure. Yeah, it probably wouldn't make sense because the date time, if your date is after 1900, small date time should be, it's tied to an original date, or it's based on and that was, I think that's what you were thinking about last night when our discussion was going. The regular date time starts out at some day in 1700.
Well, 1970 was something Professor Scudder used to talk about. That time.
I don't know, try it. You get a chance to do that tonight, and I'll stick that in there and see if that works. And if it smokes, and then you say, no, don't forget it.
Or could you cast it right there?
Pardon?
Could you cast it if it didn't?
No, because when you cast, all you're doing, you're not
Changing
changing memory. All you're doing is you're reformatting that result area, and something's got to get truncated. And that's hard to tell what's going to happen in that. This is not these are stored as two integers, an integer portion for the date and an integer portion for time. So, that's all hidden from us, so we don't know what that looks like. Primary key. Okay. So generally, when you create your table, you're going to want to designate one of the columns that is going to uniquely identify each of your records. And that's going to be treated as a column attribute. So we just put the word primary key right after that. Next week, we'll look at another alternative of doing that. Okay, so it requires that each row have a unique value. That's going to be one of the restrictions for a relational table, for relational operations to work. So what we want to do is guarantee that's going to happen. So when we put a primary key in, what we're really doing, so understand behind the scenes, some things are happening. So here I have a table. I've created my table. I'm using this little table here. And here's my primary key, whatever that is. Okay? And I'm going to start inserting records. And I'll just say it's 1, 2, 3, 4, 4 right now. When we have a primary key on a table, there's going to be another table that's created. Okay? And it's going to be an index for that table. And what it's going to have, it's going to be a table with one column in there. And it's just going to have a list of all of the primary keys. Okay, so I got 4 records in there now. And I've got 4 records with those primary keys. If I want to insert the next record, so what I'm going to do is I'm going to insert 3 something something something. should say, I'm gonna attempt to. And so what it's gonna do, when it goes to do this insert, it says, okay, first of all, before I actually go and do that, I'm gonna go up here, and I'm gonna walk down through here and see if there's a 3 in that index. Okay? That's the way it guarantees it. It says, that looks like that. No, you can't do it.
So how does the person know that, what the next number would be?
Generally, you may not know, but what you do need is usually your primary key again is going to be a semantic type thing, and so it's going to be something that would uniquely identify that.
So it could be intuitive, right?
So it'd be kind of intuitive, yeah. Yeah. And so you go ahead and, hey, I'll try it. Okay. You say, and you'll see that sometimes for some kind of identifiers. It'll say, this one's already been used. And I'm trying to think of an example. I've encountered that. I've tried to say, well, I'd like to use this name. You can't do it.
Email address.
Email address. Yeah, thank you. That's a good one. That's a
It's like a primary key and a foreign key in the same.
Okay, let's talk about foreign keys the next time.
Okay.
That's a special constraint. We're gonna keep it simple, right? And if you want to discuss that, we can talk about it after class. But I've got a big spread of people that do something about foreign key. They don't know what that is yet. Okay. So I want to keep that discussion separate next week. We'll tie a lot more things together for those of you that are already doing it. So instead it says, okay, I'm going to have to put in a 5 here. Okay. And then it adds a 5 to the index. Right. Everybody see the implications? Primary key, more space, but it has the benefit is that I now got a guaranteed way of finding these things. If I don't, then, going to have multiple entries. I can only have one primary key per table. And that has to do with the way they set up the storage. So here's an example. Employee number, I'm going to primary key. I don't have to do the not null anymore because that implies not null. Null would not be allowed. Okay. So truly unique. It's got to be a value. Got an example there. Put it all in context. Unique. Now, if I should desire to have another column in my table that was unique, but I've already used a primary key, but for some reason I want to do that, I would get too enamored with this because it's got a price associated with it. So I've got another column here. I'll just call it UN, and it's got to have a set of unique numbers. Okay. 1, 2, 3, 4, 5. When I use that unique attribute, well, the only way that we're going to ensure that you're putting in unique numbers here is create an index. Index. For primary key, this is for a unique key. Storage space. Okay. So I have a column 1, 2, 3, 4, 5. I got to keep track of the unique numbers I've got in there. So now when I go to insert the next record, it's going to do 2 lookups. It's going to look up here, do I have a match in the primary key? If I don't, I'm good. Now I'm gonna look up in here. Do I have a match in here? If I don't, I'm good. And then I'll add those. Okay. Yes.
So this is where you can potentially get off because the primary key can be 6 and your unique item can be 7 and then you're no longer matched up.
That's right, that's okay. Because it just says the value in that column has to be, now there is a catch on this one. And this is, I consider it to be an anomaly in the language. That can have one column that's null, that's unique. So typically what you're gonna do, because that's just Heartburn City, you're gonna make, if you're gonna make it a unique column, you're gonna make it also not null. So I have two attributes.
Isn't that cumbersome? Since they putting a unique clause in there?
No, it's not cumbersome.
Yeah, but wouldn't it?
No, it's not. In this case, that wouldn't be cumbersome because that's probably exactly what's happening in your personnel record. Because we usually we don't, you know, they're going to keep your social security number somewhere,
Right.
and that's got to be unique number.
And nobody else knows.
They just don't show it around a lot. What they show around is, you know, your CWID, which is equivalent to that. That's got to be unique. So typically, in a personnel record, you're going to have a primary key, and you're going to have a unique column record or column.
They do reuse social security numbers though.
Yeah, that's fine. But that's after somebody else is not using it anymore. Pardon?
They can't use it for
Yeah. Yeah.
Does anyone have a chance?
There's 10.
But the cumbersome part is, every time I insert a record, I gotta go and do lookups. That's overhead. That's processing time. Yes, that's true.
So to cut down on time, what's the benefit of putting a unique?
Forget it. You don't have an option on this.
Okay.
That's gotta be, you just gotta do that to preserve the integrity of the data. Or all of a sudden you got two social security numbers in there that are the same.
You just have to identify your data.
That's right.
And then-
You want to, yeah, that's it. Identify it and use this very judiciously. That one. Primary key you gotta have.
So just don't throw that command around all.
Yeah, that's what, exactly. Just don't get carried away with it. And you don't get to choose that anyway. Your DBA is gonna, you know, if you were doing stuff like that, your DBA would be saying, man, wait a minute. You're asking for all these indexes and you got 1 million records in here and all of a sudden. It's mostly for insight. Okay.
Do you have two columns in
Yeah, I can have another unique column, yeah, there's no limit on that. I can only have one column that's primary key. That's the point. Okay. The populate table. Okay, here's I got a little table here, and here's my data. And I got data in my data set. Wow. This is sitting in a text file, and
It's okay, Excel will do that.
okay. And it's delimited by the pipe symbols. And we like to create a table that had, you know, these columns in there, and then populate it with those values from that file. And you don't want to do that with inserts. So, one insert statement at a time, but we do have a nice command, which is not in your book. That's the bulk insert. But you used bulk insert before? Okay, so we got some smiling on that one. Knew where I was going with that probably, huh? All right. So bulk insert, keyword, and the table name. It's the table I've defined. From, and here's the file. Got to give it the full path. Okay. And I've got to specify the field terminator. This would be that pipe symbol. Okay. And then a row terminator. And if we looked at our rows back here, this was out like a text pad file. Then the rows must have been terminated with a new line. Okay? And then this is simply says that the first row in there is going to be numbers. That's the default. I don't have to put that in. I think there's another term if it's got the headers up there so that it knows not to read that first row. And if you want to see the whole capability of this thing, you go out to MSDN. You can do probably then do the keyword bulk insert, and boy, you get a nice page. It gives you a good description of all the details. But we probably are not going to read all of that. We're just going to read something just simple.
For a new line, are you going to use /n, or is there something else?
That's what you're going to use, backslash
Slash
n. I forget it, but I've got it. The character for new line is backslash n.
Where would that go?
Pardon?
Where would that go again?
Right here.
The road term?
Row terminator. Okay.
Why is this not in the book? Is it just because it's?
Yeah, I haven't any idea. They probably just didn't figure that you'd be doing something like this.
So how's the best way to study for it with regards to the final?
The slide.
I'm not, huh? The slides, yeah, the slides in this case. I probably not, I don't think I'll ask the question. Yeah, I don't think I'd ask the question. I don't think I'll ask the bulk insert question. We're only gonna do this for this probably this one time when we talk about the table, because everything else will be related to, inserting them a row at a time with the standard insert statement, which is, well discussed. And we'll do that next week, which is, the Mirage folks discussed that. But I added this because I see it's so powerful. It's a nice construct. But, that being said, probably not too many people use it anymore, because if you're using the Microsoft integration services or something, they got GUI built around this whole thing, and all you do is do a pick and a click, and then voila, everything goes in.
So there's no import,
Export, pardon? Yeah. And Access has got a pretty nice one too. It's real easy. It's all GUI driven. But, I tend to like this old stuff, so I show that one. And let's see. All right, so let's. What we're going to do is everybody got a SQL Server session up. Usually, I'll give you a few minutes to do it. I assume you've got that up. Yes, no? Yes. Okay. All right, so let's do something here. Example, where's my key? Object Explorer. Okay. So first step is go out and create yourself a new database. We're just going to create an employee table. Actually, it's going to be the one in the PowerPoint. And I'll actually put that PowerPoint up. So I'm going to create a new table, and this is a case where, a new database, where I'm going to actually create the table and execute the query for the table definition, and it will put it in, and then we'll populate it. So first thing is, I like to call this EMPDB. Okay, I'm just going to, anything you want to call it. And so I'm going to say OK. And so there I've got an employee database. Okay. Got no table. All right. Now, this is the table that I'm going to have you put in. And the argument that we would use is if we looked at that data on, I'll do this, is that if we look at the data, I wish I had two screens here, but I don't. That. Is that if I look at that employee number, let me see if I can get that. I'm going to give up on this thing right here. Just give up. I got stuff out here that takes that. I've got my file out here. So and then I've got something here. Okay, here's an example of the, make that a little bit bigger, format, font, I think I've got 18, okay. So, if you were to do this type of thing, what you would do is you come along and you look at the values on here, and you say, here's the first column, and that's going to be associated with the employee number. So I can get by with a tiny int, because that's less than 256. And then variable character. I mean, that's a given, because I got a name in there, Barry. Okay. And then age. Okay, that's a tiny int. Rep office. Okay. And that's a tiny int. That's the next field. And then your title, sales manager or sales rep, that's a variable character. And hire date, we'll go with small int. And then quota, we want money. So, you'll go ahead and type those in. Yeah, in just a query window. I'm going to do this. I'm going to go ahead and pop mine in here and make it easy so you can see it. So I'm going to come back to here. And I'm going to open up a query window, and I'm going to use Control V. So this is one solution to creating that employee database. I'll give you a few minutes to do that. I could probably make that a little bit bigger. What have I got? 16. Let's see if I can get that about it. I did an indent here, so I got employee number, tiny int, not null, primary key. Okay. And the not null wasn't necessary there. That was again old time thinking, because there was a time when SQL Server, for example, allowed nulls for primary key. They changed that with 2005. So that just Once you get that typed in, you execute that like a query, and then you can see, did I get a table? And probably some of you don't have the difficulty with that. And all it says is commands completed successfully. That's what you want to see. You do a little refresh on here. Refresh. And if I dropped it down, then I see, yeah, there's my table with all my columns. I'll give you a few minutes
Sales
to
money
do.
the last thing?
Pardon?
Is sales money the last?
Yeah,
Okay.
yeah, sales, yeah, I'll pull it down.
Where's the data that it's supposed to be acting on?
We're gonna put that in, and we haven't done that yet. All we've done is constructed the table. Okay? All we've done is construct the table.
If we called it EMP, then what's it saying EMPDB?
I'm sorry.
We call it DMPDB.
Us is the name of the database,
Oh,
this is a
yeah,
table
that's
in
right.
there.
Okay, that's right.
That's all.
Did you page? Why's that?
Got it once, that's good enough. Okay, what I'm going to do now is I got to give you that file, and so I'm going to put my I'll put my two things out here now on. Go out here and desktop. I got handouts. I don't have handouts. I'm going to create a folder. Handouts. 05 handouts. Okay. And I'm gonna copy, I'm gonna copy that, paste that. Okay.
Put it out there, fine.
That's I've got the program file. I'll do that. Where's mine? Okay, here's mine. Put all three of these things in there. 1, 2, 3. Okay. Copy. Copy. And so I'm going to come back to here and do that paste. So I'm going to put some handouts out there now that has the PowerPoint, has field names, we already have that. This employee.txt is this text file. What you want to do is then copy that text file to the root on the C drive. Because that's where we're gonna read that thing from. So I'm gonna go back one, I'm gonna copy this, copy. And now I'm gonna go out here to the iDrive and put that out there. And do paste. So I'll do that. And here's my handouts number 5. Okay, and there's my C drive. I'm going to do a copy on that. And I'm going to put it right on top of the C drive. Paste. Okay. When I do that, it's out there on the C drive. So I'm going to come back to here. And here's my construct for populating the table. So I'm going to copy this. And I'm going to go back to my SQL Server, and you can do the same thing, or you can type it in. I'm going to do another query here. My path was at the root of the C drive. Put it anywhere you like. That's a good idea. And then I had the field terminator with the pipe symbol. And then here's the new line. And then now all I have to do is make sure I'm in the employee database now. Okay. But I'm going to insert it into the employee record, okay, or employee table, and now I'm going to execute that. And wow, that's what I wanted to see. 6 rows affected in a positive manner. Okay. And now I'll do another query that says, oh, you're not finished typing them. Good. All right. Then we'll do a select star to see whether we get it populated. There's populated. Works fine, huh? You been using box insert?
No,
You don't get to modify, you don't get to create your tables anyway, do you?
they're already created.
Huh?
I insert into them,
Yeah, you insert, but you don't get to do that.
and I updated something wrong, and it
Yeah, I know you
updated.
said that. But when you start to update things, what you want to do is do a select statement, say, this is the way I'm going to update, to make sure I'm doing maybe 1 or 2 and not the whole table. You gotta have that.
Well, I copied some code offline. And
Yeah, it's
some
gotta be
goofiness.
careful. It's set operations. It does everything unless you put that filter in there.
It just had the wrong filter.
Huh?
It had some like where exists
Yeah, it
thing
did.
on it, and
I
it
don't
just
like that. That was dangerous, too.
Oh, mine works.
You got yours? Okay.
I just copied it from you, so it should work.
Okay. Okay. All right. Okay.
A new query.
Make sure you got your employee database showing. Don't put it in master or something like that.
It's a pipe.
Pipe symbol, it's
above the enter.
above the backslash. Okay. New
You can put
query.
them in the same query as long as you highlight it.
Select
Only the highlighted thing gets executed. You
Star.
just got to be
From.
careful about making sure you highlight it.
EMP.
But that way you don't have to start a new one every time.
Okay.
It's really nice.
And execute. Wow, that really looks great. Okay.
That's going to be coming off of the C drive though, right?
That's right.
Because mine's not finding.
You have to put it on the
Oh, I know why. I had this DMP.
Okay, program number 5. For those of you who want to get started. Relational data using MS. Older data. Okay, so what I have here is a little distributor, and actually you've done something that looks like one of the tables, but it's really not. It's going to be a little bit different. And we have a set of files out there. And I've got about 5 tables. And it's got files with the data in it. And your assignment will be to create these tables and populate them, select the appropriate primary key, and then show a database diagram showing that you got the tables. You haven't connected them yet. Next week we'll look at how to connect those tables. We'll also look at how to insert some records into those tables. Okay. For this week, this will be for some of you it'll be a real easy assignment. For others it'll be it may be a little bit challenging. The last time I did this, I had to do the stuff that I was going to have you do next week too, and it's when I filtered out some of the folks in the class. Okay, so we don't want to do that. We don't want to lose anybody. So this will be mostly practice on creating some tables. Now you have to create these on your own, and you got to figure out what data matches up. So you got to kind of go through and say which data type would that fit into. So you've got a good example now how to do it. And I'm going to put that out there, and it's going to be. And I think I've got all of that in one little folder. It's going to be in that handout. Let me go back up here. It's going to be okay. Program 5, table construction. Okay, I got the files and the program. And copy. Now I'm going to go out to the iDrive, and I'm going to go out to here, and I will
Bottom one.
and I will put it in here. Table. And if you open up Aztec sales data file, if I open that up, I've got 5 tables, and I got a table or a table here, the field names for each of the tables. And then here's the a description of the assignment. So all you're creating is a database with some tables in there, and you're going to populate them, and your only requirement is to get the right data type, get the right column attributes, identify a primary key. Okay. Just like what we did here for this little employee table. Is that good for everyone?
Everything we do on seasonal here disappears, so how would we keep that, are we gonna work off the same aspects?
Okay, I'll have some that we'll do next week in class, but what you can do is to do all of these tables and the bulk inserts in one script, so that when you come in here, you run that whole script, just like we do the riverbed.
Okay.
defeat. Where is it? Oh, I didn't put that out there. I wasn't there. Okay, and I will, for those of you that are gonna need help from your tutor, I will send her a copy of the solution. So where am I on the desktop? So your solution, so what you can do now is this is probably the better option rather than the MDF files, because you never get it, you always get a mismatch on platforms and stuff like that. So your so the program solution, oh, I've got these in 3 separate things. And I may have one that says build the whole thing all at once. Let me see if I've got it like that. So I've got 3 separate ones, and then I think I glued them together. And so, okay, this one's, this is going to look kind of confusing, because what happens, this is going to be the solution that you'll have at the end of next week. And so you can have everything in one table, or one script. And so that may be a little overwhelming for you right now. So if you come in and create separate scripts for each table, say like, let's look at something that was associated with, where's the sales rep? Sales reps, that's what, just like that. Okay. So each table in here, I have, essentially the description of the table, and then I'd have the bulk insert statement, then I have a select statement right after that. So, but once you create that table, make sure you comment that thing out so you don't do that. And then be careful that, you're on your insert. Okay, you don't do an insert again, because you just can create another duplicate set of records. Okay. So typically, once you know that you got that to work, then you take out that, and then your script would be, I'm going to go ahead and create the table. I would put a go command in here, because what it means, it creates it as a separate batch. So it creates the table by itself first. Then if you got problems, it doesn't try to run the bulk insert. So once that's good, then it goes ahead and does that, and you'd have I put another go in here, and then you'd have the select statement, and that's what you see when we do the river band. Except I've got all of those files glued together on the river band. So I wouldn't try to do that now, because that's maybe a little bit too sophisticated. So if you do a script for each table and the .SQL file, will come in here and run them all.
What's called going on stuff?
That's an old command line thing. So it's not a SQL server. I mean, it's not a SQL command. It's SQL server. It simply says, I'm gonna do this one first and make sure and actually execute it. Then I'll go and then parse this one and execute it, and then parse this and execute it.
Okay.
That's from the old command line world. After I've got a set of statements, go. Not stop. I want to go. It means go and do what I've done, and then I'm ready to do this, and it's go. Okay. All right.
Can we do it in 3 separate queries as we did it?
If you want to do that, I'm trying to help, because if you want to come back in here and load up your solution when you get here next week, then you'll have a nice script to do that. Some of you may be comfortable, I'll just put them all in one, like another rip. Yes, sir.
You said you attached the database diagram, what you want for that? Like a screenshot or?
No, you can print it out.
Oh, so just submit a separate
Yeah,
paper.
it's going to be
Okay.
real because this is gonna be pretty small, it's not gonna be like the river bin, it's gonna be on one piece of
Okay,
paper.
basically, you just want to see the table.
Yeah, yeah, with it, yeah, don't give me the select statements with them, I know those, I just wanna see that you got the paper.
Okay.
And then next week, we'll do it again, but we'll connect them together, and you'll see the constraints.
So it just.
We all good with that?
Number 4.
Yeah, I'll figure that out. Okay? All right. That's it.